Hi, today we'll be going over arithmetic sequences. Now, arithmetic sequences are a pretty interesting part of algebra that show up a lot in word problems or just math in general, and it can be kind of difficult to wrap your head around at first. And you'll need to understand them if you're going to complete homework or assignments or tests. So here we're going to go over arithmetic sequences and give some ways to make the whole process of solving them easier, right? So first of all, what is a sequence? Well, a sequence is just a collection, if you will, of numbers, right? So 4, 9, 14, 19, right? That's a sequence, just a collection of numbers. Some sequences are finite, meaning they have a set of number of terms, right? You can say, okay, well that has 1, 2, 3, 4 terms, right? Others are infinite, meaning they go on forever, right? And we don't really know exactly how many terms they have. They have infinitely many terms, right? Which is difficult to quantify. But we'll notice in both of these sequences, we have an interesting phenomenon. Every value is 5 greater than the value before it, right? To get the next value in the sequence, I can just take my current value and add 5. And this becomes important when we decide to formalize this as arithmetic sequences, right? This is what an arithmetic sequence is, where every term, every value, every number in the sequence has a specific common difference between it and the previous term, right? If I were to do the fourth term minus the third term, I get 5. If I were to do the third term minus the second term, I get 5. If I were to do the second term minus the first term, I get 5. They all have a common difference between two terms next to each other of 5, right? Because we always add 5. That's what an arithmetic sequence is, right? Where there's a constant relationship between every single term by a certain number, whether you're adding a certain number or you're adding by a certain value or you're subtracting by a certain value. And a lot of times problems will ask, hey, what's the 90th value of this sequence? And we could just sit here and write out the 90th value of the sequence, adding 5 every time, but that's a lot of work. And there's probably an easier way to do it. So first, I'm going to represent that 90th value by saying, hey, I have a arithmetic sequence A, and I want the 90th value, right? Or just say, let's keep it simple and say I want the nth value, or n is a given number, right? What's that going to be? Well, I could say, since I know that for every value I'm adding 5 to it, it's just the value before it, or the n minus 1 value, plus 5, right? We could say that. But that doesn't really work, because if we were to say find the 90th term, we have the 90th term is equal to the 89th term, or 90 minus 1 plus 5. And that doesn't help us because we don't know what the 89th term is. So what can we do to find our values without having to rely on finding the previous value and then the previous value and so on and so forth? Well, we can notice one thing, right? So we see that for every term except the first term, we're always adding 5. Like here, we just added 5. Here, we just added 5. Here, we just added 5. So if we were to count the first term, then all the times we've added 5 except the first term, we would have our every single value for the sequence that I wanted, right? So I can say, so for a given sequence number, right, for the 90th term, right, that's going to be the first term, the 1, plus all the times I've added 5, or what I'm going to say is my common difference. So the common difference d, right? So I'm going to say d equals 5. since I've added 5 for every value except the first, I'm going to have n, all the values that I'm currently looking for, minus 1, excluding that first term, and then times that common difference, which is 5. So if I wanted to find a to the 90, right, I'd have the first term, which is 4, plus 90 minus 1 times 5, or 4 plus 89 times 5. If I were to do the math on that, I would have 449 as my answer. As you can see, that's really, really helpful to be able to use a formula like that to find out what the value of a given term is. Because if we were to sit here and write out all the time you've added 5 up until the 90th term, that would be a whole lot of work. But here, with this nice formula, we don't have to do that. So what is that formula? I'll just make it a little more clear. The formula is this, right? If you want to find a given term in your sequence, that's the same as adding your first term in your sequence plus your common difference times the term you're looking for minus 1. Right? Because remember, we can't include that first term because in that first term we haven't added 5 to it yet. And that is the formula that you'll use whenever you want to find the given term of an arithmetic sequence. If you want to find the common difference, it's even easier. You just look at what's being done to each and every term, what's being added or what's being subtracted, and that'll be your common difference. And that's arithmetic sequences. I hope you enjoyed, and I hope you have a great day.